Hello everyone. Today we'll be looking at some quick solutions of the chemistry section of All India Akash Test Series JEE Main 2019 Test 3 Code ENF. So let's start with the first question. Question number 31. Which of the following reaction produces carbocation as an intermediate? So looking at the options, in the first option students, we have a tertiary alcohol. So students, we know that a tertiary alcohol will easily undergo dehydration to form a tertiary carbocation which is very stable. Okay. So the first reaction produces a carbocation. Let us look at the second option now. In the second option we have an alkene which is to be reacted with H2SO4. Students, this H2SO4 will provide us with H plus, and then this H plus will go and attack the alkene. So students will have the generation of another tertiary carbocation. Okay. So the second reaction also produces a carbocation. Let us look at the third reaction now. In the third reaction, we have a secondary halide and then we have AlCl3. So this AlCl3 is a Lewis acid and it is going to extract the Cl minus from the alkyl halide and it is going to generate a secondary carbocation. Students, we can see that carbocation is formed in the third reaction as well. So the correct option for this question is option 1. Let us look at the next question now, question number 32. In the given reaction sequence, students, we have phenyl cyanide and we have cyclopropyl magnesium bromide. So this Grignard reagent will attack the carbon of the cyanide group and then it is further subjected to hydrolysis. So if we draw the product form, so in the first step, we'll have the attack of the anion and then it is subjected to hydrolysis, then we'll have the generation of a ketone. Let us look at the options which follow. So this is our compound A and the examiner is interested in knowing the type of test which is given by this compound A. So the compound A will not give tolerance test. Tolerance test is given by aldehydes. It will also not give Fehling solution test. It will also not give Benedict test. All of these are tests for aldehyde. So it will give the formation of cyanohydrin on addition of HCl. So students, we have to mark option 3 as the correct answer to our question. Let us look at the next question. Question number 33. In the following given anions, so students, we have been given 3 carbon ions and we have to comment on the order of their stability. So if you look at the first carbon ion, the first carbon ion has 6 pi electrons in complete conjugation. So this is an aromatic anion. If you look at the second carbon ion now, the second carbon ion is resonance stabilized. So if we try and draw the resonance structure, so the negative charge will get delocalized within the ring and it will eventually shift to oxygen, leading to the formation of this structure. So the second structure is resonance stabilized. And if we look at the third structure now, in the third structure, the electron withdrawing group is present at the meta position. And we know that the mesomeric effect or the resonance effect is not felt at the meta position. So no minus M or minus R. So it will just exert its minus I and it will lead to the least stabilization among all 3 of these molecules. So students, we can see that 1 is going to be the most stable because of its aromatic nature, followed by second, in which the negative charge on carbon is resonance stabilized, and the least stable among all these three structures will be the third one, in which the negative charge is stabilized by a very small -I effect. So looking at the options, we have to select option 3 as the correct answer to this question. Let us look at the next question. Question number 34. So we have been given 3 compounds and we have been provided with the energy required to break the indicated CH bond. So the examiner is interested in knowing about the correct order of energy of breakage of CH bond homolytically. So students, we know that the homolytic cleavage will lead to the formation of free radical. So greater the stability of the free radical, lesser will be the energy required to break the CH bond homolytically. So let us first look at the radicals which are generated in this case. So in the first one we have a benzyl radical. In the second case we have a tertiary butyl radical. And in the third case we have a substituted radical which is both allylic as well as benzylic. So on comparing these 3 free radicals, we can see that the most stable among these will be the third one, followed by the first one, as benzyl radical is more stable than the tertiary butyl radical. So this is the correct order of stability of the radicals. So the energy required to break the CH bond will follow the reverse order. So if we try and link the stability with the bond energies, so we'll have the order in which the bond in the third structure will break the most easily. So Z is going to have the least value, followed by X, followed by Y. So students, looking at the options, we have to mark option 1 as the correct answer to this question. Let us look at the next question. Question number 35. Which of the following reaction produces a radical? So we have been given 4 reactions and we have to figure out if the respective reactions lead to the formation of radicals or not. So if you look at the first structure now, the first structure has a peroxy linkage. So peroxy linkages are not very stable. It is going to break up upon heating. So it is going to generate RCOO radical. Now students, what will happen is this CO2 will leave from this. So if we have the loss of CO2, we'll have the formation of radical. Let us look at the second option now. So in the second option, we have R and double bond N R. So upon heating, this will also lead to the formation of 2R radicals along with the evolution of the N2 gas. So we can imagine the homolytic cleavage of these 2 bonds, which is going to lead to the formation of radicals on N and R, and the NN radical will combine to give us N2, which escapes. Looking at the third reaction now, Cl2. So Cl2, when it is subjected to photolysis, it breaks up to give you 2 Cl radicals. So the third reaction also involves the formation of radicals. Now if you look at the fourth structure now, in the fourth structure we have electrophilic aromatic substitution of benzene, in which chlorine is substituting a proton. So students, this reaction does not proceed via radicals. It involves the carbocation mechanism. So students, out of the given reactions, only 1, 2 and 3, they lead to the formation of radicals. And students, we have to select option 1 as the correct answer to question number 35. Let us look at the next question.